Podcasting from the Deep Sage 9 Observatory in the high desert near Taos, New Mexico, this is the Deep Sage 9 Starcast. Welcome back to the Starcast for the week of March 8th, 2026. I'm your host, Jay Shaffer, and with me is my co-host, Mike Lewinski. How are you doing this morning?
You know, Jay, I'm suffering a little with that time change, but I'm not going to complain too much. It's a beautiful day here. How are you doing?
Good. Yeah, that daylight savings time. I'm a proponent of just standard time because the sun. But and the sun moving along the ecliptic. Um, Mike, what's our space weather looking like over the next couple days?
Well, Jay, there are a few sunspots facing the Earth right now, but they all have stable magnetic fields and pose no real threat of strong solar flares. And correspondingly, we get a chance of 20% for M class or 1% for X class over the next 48 hours. There was, however, a solar wind that arrived yesterday, March 7th, and that kicked off some minor G1 class geomagnetic storms with Arctic aurora. More storms are possible again today as that solar wind continues to blow, keeping an eye on the planetary K index at about 4. There are currently no significant equatorial holes on the sun that are facing the Earth at this time. So, what's going on in the night sky this week, Jay?
Well, as seen from Earth this month, the bright planet Jupiter will be high and bright in the sky as darkness falls each evening. It'll be visible through several hours before dawn. So, if you're out around 9 or 10 o'clock at night, look almost straight up, and the brightest thing that you'll probably see is Jupiter. And also, Venus and Saturn pair up this week. They're closest to each other on the evenings of March 7th and 8th, and the 8th, of course, is tonight. But you'll have to get outside soon after sunset to see them. Look for them on the in the bright western twilight. Looks like two little, probably the first stars that you will see, quote unquote stars. Uh, and then sometime after tonight, Saturn will be lost in the sun's glare and slip out of the evening sky. And with Saturn disappearing, the last month's somewhat overhyped parade of planets will come to a close. The moment of the third quarter moon will fall on 9:38 UTC on March 11th, and that's 4:30 a.m. Central Daylight Time, and it arrives after midnight on your local time, and then set again around noon. So look for it high in the sky before dawn, and that also means that you'll be able to get dark sky observing in before midnight. This is also the season to spot the zodiacal light, sometimes called the false dusk or the false dawn. Zodiacal light appears along the ecliptic plane. And what is the ecliptic, you ask? Well, we'll answer that question later in today's discussion. But first, here's Mike with Space News.
Hey, Jay. We've got a couple fascinating stories this week that really highlight the scale of what we're doing in space, from the microscopic to the massive infrastructure of mega-constellations. So, first up, researchers are talking about tardigrades of the galaxy. We all know tardigrades, those nearly indestructible water bears. But a new study out of Penn State tested just how they might handle Martian soil. And it turns out that those indestructible little water bears might be the key to figuring out how we survive on Mars.
Well, I'm guessing that if anything can survive on the Martian surface, it's a tardigrade. I mean, they can survive the vacuum of space after all.
And quite severe radiation. They have ability to repair their DNA when it gets damaged, and they've got extra copies. But when it comes to Mars, it's actually a bit of a mixed bag. When they put active tardigrades into the simulated dirt, their movement slowed down almost immediately. In some of the more global soil samples, their activity dropped to zero within just 2 days. It turns out that the minerals in that dust are pretty harsh on living tissue.
So Mars is even too tough for the water bears?
Well, the team found one simple trick. If you rinse that Martian soil with water first, the tardigrades will bounce right back. Washing away the toxic salts and reactive minerals made the soil suddenly habitable.
Well, that might be a problem considering how little water is actually on Mars, but that's a massive insight for future Martian greenhouses. If we can wash the planet, we might actually be able to grow something there.
Right, and it's a double-edged sword. The researchers noted that while the soil's natural toxicity is a hurdle for farming, it actually acts as a planetary shield, and it might be the very thing that prevents us from accidentally contaminating Mars with earthly microbes. So it's fascinating to look at how these tiny tardigrades are helping us map out the ethics and logistics of becoming a multi-planet species.
Yeah, of course, there's always the ethical dilemma is do we infect Mars? From microscopic bears to massive rockets. So you also have an update on the physical footprint we're leaving in the upper atmosphere closer to home, right?
Yes, and this one is a bit of a wake-up call. Scientists have officially published the first direct measurement of space debris pollution in the stratosphere. For years, we've talked about Kessler syndrome and orbital crowding, but this research shifts the focus to what happens when hardware actually burns up in the atmosphere.
We always assume burning up just means disappears, but I'm guessing that's not the case, huh?
Exactly. In February 2025, a SpaceX Falcon second stage had a malfunction that left it drifting for 18 days before it finally re-entered over the North Atlantic. A research team at the Leibniz Institute in Germany happened to be running a high-powered LiDAR system at the time, and they caught the smoke from that re-entry in real time.
Yeah, using lasers to find a needle in a haystack. What did they actually find?
After about 20 hours after the rocket hit the atmosphere, they detected a massive spike in lithium vapor at an altitude of 95 kilometers. To give you an idea of that scale, natural lithium from meteorites is extremely rare. We usually see maybe 3 atoms per cubic centimeter. After this single Falcon 9 came down, that count jumped to 31.
Wow, that's a tenfold increase from just one rocket stage?
Yes, the math is what really gets you here. The entire planet only receives about 80 grams of natural lithium from space every day. A single Falcon 9 contains roughly 30 kilograms of it. And between the aluminum lithium alloy in the airframe and the onboard batteries, we're essentially injecting a decade's worth of metallic pollutants into the upper atmosphere in a single afternoon. And, that may have been an accident, but we are, putting batteries on every single satellite that we are launching that we intend to deorbit.
Yeah, and it's not just about like a one-off accident like this case. We're looking at a future where we've got multiple reentries every single day, right?
Yeah, that's the real kicker. SpaceX just filed a proposal with the FCC for up to 1 million satellites to serve as orbital AI data centers. Even if that's a ceiling and they only launch a fraction of it, the replenishment cycle alone would mean hundreds of satellites burning up every week.
1 million? It's hard to even wrap your head around that number when we already see these kinds of chemical spikes in the current constellation size.
Exactly. The study proves that the vaporized metal doesn't just disappear, it stays up there. And we still don't fully understand the long-term effects it might have on atmospheric chemistry or ozone depletion, or I should say, our Earth's magnetic shield. We're changing it with the volume of metal that we're putting up there. So it's a sobering reminder for all of us who love the night sky that out of sight shouldn't mean out of mind.
As you and I can both attest, Starlink satellites are far from being out of sight either. I mean, since we see over a hundred flares at least practically every night. And that brings us to our topic for today. We spend a lot of time talking about our smart telescopes and deep space targets, but sometimes you just gotta know where to look. And we live in a world of GPS, planetarium apps, and go-to telescopes. but there's just something grounding about understanding the celestial grid, the actual geometry of the sky, and finding your way around.
Yeah, it's funny you say that, Jay. People see the stars as this random scatter of light, but it's really a series of nested disks. If you can visualize the ecliptic and the galactic plane, the sky starts to make a lot more sense.
Right. I always tell people to start with the ecliptic. It's the main street of our solar system. It's the path the sun appears to take across the sky over a year. And since the planets and the moon mostly sit on the same flat plane, if you see something bright that isn't a star, it's probably a planet sitting right on that line.
Because we're looking out from inside that disk, the planets don't just wander anywhere. They follow that narrow track. But it gets weird, doesn't it? They don't all move at the same speed, and sometimes they look like they're literally backing up.
Oh yeah, you're talking about apparent retrograde motion. The old thing of Mercury being in the retrograde and that affecting our human behavior. That's a classic head scratcher for beginners. Imagine you're on a highway or a NASCAR track, passing a slower car. For a moment, as you pull ahead, the other car looks like it's moving backward relative to the surrounding landscape.
Yes, exactly. The Earth is on the inside track compared to the outer planets like Mars or Jupiter. As we lap them in our orbit, they appear to slow down, stop, and then drift backward against the background stars for a few weeks. It's not that the planet actually reversed its orbit. That would be a bad day for the solar system. It's just a matter of perspective from our moving platform here on Earth.
Yeah, it's a great reminder that we're on a moving spaceship. But while the ecliptic is our local neighborhood, we can't forget the city itself or the galactic plane. That's the actual disk of the Milky Way galaxy, and it's tilted about 60 degrees relative to the ecliptic. So when we're out in the dark side and we see that massive dusty band of light overhead, we're looking directly into the heart of our galaxy.
Yeah, especially when looking at the constellation of Sagittarius, which for us is going to show up in our southern sky just a little bit before sunrise this time of year. It's like being inside a giant dinner plate looking out toward the rim. And since our solar system is tilted, we're essentially diving through the galaxy at an angle. It makes the 3D map of space feel a lot more real when you realize that our local street is crooked compared to the city grid layout of the Milky Way.
Yeah, to continue the analogy, once you know where the streets are, you still need to find a specific address. Brings us to coordinates. Now, beginners usually start with altitude and azimuth, which is simple. Altitude is how high is the object you're looking for from the horizon, with 0 degrees being the horizon and 90 degrees at zenith, and azimuth, which is the direction from 0 degrees north to 180 degrees south, 270 degrees west, and so forth. And like when you and I report meteors to the American Meteor Society, that's how they categorize the instance of the meteor. So they know the time, and then we give them the time, the altitude, and the azimuth, and that's how they track meteors.
Yeah, and the problem that we have with alt-az is that it's tied to you standing on the ground. Because the Earth is spinning, a star's address changes every minute. And that's why we use the equatorial system. We project the Earth's latitude and longitude out into space, and we call that declination and right ascension.
Yeah, and those are abbreviated delta and alpha, right?
Yes.
Uh, those coordinates stay fixed to the star, so they work no matter what time it is. That's how we can share the coordinates for a nebula or a galaxy, and everybody knows exactly where to point, regardless of their time zone. But Mike, for someone just standing in their backyard without a computer-controlled mount, how do they translate those fixed star maps into what you're actually seeing?
Well, that's where the planisphere comes in. This is basically a analog computer that you operate manually. It's two plastic discs. One has a star map in equatorial view, and the other has a cutout window that represents your Alt-Oz horizon. Um,
Walk us through it. If I'm standing out there at night, how do I actually use this thing?
it's almost too simple. You just rotate the top disk until the current time on the edge aligns with today's date on the bottom disk. That's it. The stars inside that oval window are exactly what's above your head right now.
But orientation matters, right? If you're holding it like a book and looking down, you're not gonna you're gonna get lost.
Yeah, huge point. You have to hold it up toward the sky. If you're facing north, put north at the bottom of the map. The center pivot point is Polaris, the North Star. Everything else on that map rotates around that one point, just like the real sky does throughout the night. It's really the ultimate tool for learning how the fixed map of the universe meets our local perspective here on Earth.
Yeah, and you were saying that you use a planisphere quite often, or you have a sheet that you print out, or
Yeah,
to
I
identify.
have some star maps that a friend actually made. He was doing astronomy in college, and he made his own, and they're really good. And what I like about these is that if it's a cold night, I can have a campfire and then use the star maps as shields to protect my night vision, and they're illuminated from underneath. So that's, one of the problems that you're going to have with a planisphere is that you need to be able to see in the dark. And so red headlamp, red LED headlamp is probably the way to go there, and that'll work too. Um, I just found it nice to stand around the campfire with the star maps in hand, looking down at them, looking up, and I memorized constellations. I pick one that I like a lot. In the winter, that's going to probably be Orion. Um, and in the summer, I'm going to start with the summer triangle, and then I just work my way around the sky, identifying the constellations. And you do that for, a few times on a camping trip or, once a month, and you're going to get the sky mapped out in your mind, pretty quickly.
Yeah, and I'm still, learning. I couldn't point to every single constellation in the night sky, and I've been at it for years. But having a planisphere is invaluable. In general, I can do some star hopping, and I know you can go from Orion to Sirius to Gemini to Procyon and so on and so forth, and but knowing that if there's something on the ecliptic, is that it's probably a planet, and that's always been my go-to for impressing friends and family and beginners. Is they go, "What's that up in the sky?" And you look up and you go, "Well, let's see. It looks like it's on the ecliptic. Well, that's probably Jupiter." So, yeah, so that's kind of how we find our way around the neighborhood. And
And maybe a quick shout out to the augmented reality apps, in a pinch. I think that's also a very helpful tool for, hold your cell phone camera up to the sky with, one of the Stellarium or other apps that we've discussed previously, and you can pretty quickly start to identify constellations that way as well.
yeah, and to me, that's the kind of like old school was the planisphere, and I think that it was really a barrier to adoption for a lot of people that had an interest, passing interest in astronomy, as they were just going, this is just too hard. And with apps out there, and especially augmented reality apps now, it is just it's really a lot easier to navigate your way around uh, the night sky. And so, you know, the bright light that's in the sky and what is it can usually easily be answered by uh, installing an app on your phone.
That's right.
Okay, well, we want to thank all of our listeners for checking out the podcast today. And please be sure to comment, like, and subscribe, and let us know what you'd like to hear more about. And you can also check out our individual websites. Wildernessvagabonds.com is Mike's site, and skylapsers.com is my site. And you can also check out our YouTube channels. Mike's is Mike Lewinski YouTube channel. And of course, mine is branded as Skylapser YouTube channel. Our intro music is Fanfare for Space by Kevin MacLeod from the YouTube audio library. And from the Deep Sage 9 Observatory, this is Jay Shaffer and
Mike Lewinski.
wishing you all clear skies.